Assalamu alaikum. This is Mahmoud Akhtar Oiti. Today our topic is cryptography, scissor cipher, and one-time pad. Moving on to the main part, we will talk about three terms which are cryptography, scissor cipher, and one-time pad. Cryptography is the process of hiding or coding information so that only the person a message was intended for can read it. And scissor cipher is a substitution cipher that shifts letters in a message to make it unreadable if intercepted. And lastly, one-time pad is an encryption system that is unbreakable providing certain conditions are met. Here are some basic terminologies which are uh, which are important to understand the main encryption or in cryptography. Plain text is the original message and ciphertext is the coded message. Cipher is an algorithm for transforming plain text to ciphertext, and key is an info used in cipher known only to sender or receiver. Encipher and decipher are converting plain text to ciphertext and vice versa. Cryptography is the study of encryption principles or methods, and cryptanalysis is the study of principles or methods of deciphering ciphertext without knowing key. Lastly, cryptology is the field of both cryptography and cryptanalysis. Cryptography is divided into two parts, which are encryption and decryption. Encryption means converting plain text into ciphertext, and decryption means converting ciphertext into plain text. Both of them follow specific formulas. Encryption follows C equals to P plus K. Here, C equals to ciphertext, P equals to plain text, and K is for key. Decryption follows the formula which is P equals to C minus K. Again, P is for plain text, C is for ciphertext, and K is for key. Plain text are readable, ciphertext are unreadable or encrypted text, and key is used for encrypting or decrypting. Now we will see Caesar cipher example for encryption part. Here is a box with index and some here is a box with index and characters, and we will now convert plain text into ciphertext. Here we have taken an example which is apple. As we know, encryption follows the formula which is C equals to P plus K, which means plain text index plus key equals to ciphertext index. Here 1 plus 5 equals to 6, 16 plus 12 equals to 28, and 16 plus 5 equals to 21, and rest are same. Such we have converted the plain text into ciphertext. But there is a rule. If the ciphertext index is greater than the main index, then the math will be slightly different. Then we will divide the cipher index with 26. Here 28 is greater than the main text index which are lastly in 26, so we will divide 28 divided by 26, and if result will be in fraction, minus the integer number which is minus 1, and if the result in fraction, always use the upper bound. This is how we will do Caesar cipher example and in encryption. Now, if we will talk about Caesar cipher decryption, here we have the same box with characters and index. In this part, we will convert ciphertext into plain text. We have taken the previous ciphertext FBUXM, and we have converted it into the same plain text. Now the formula is P plain text equals to Ci minus K, which means ciphertext minus key. Decryption works with minus key. So here 6 minus 5 equals to 1, 2 minus 12 equals to minus 10, 21 minus 5 equals to 16, and the rest are same. This is how the decryption part is done. Now we will talk about the shift cipher or scissor cipher code. Here we have written a code for replacing characters in strings. If it is not character, then we will return it. Then the offset, if the offset equals to 65, then if not, then we will move to offset equals to 97. Then to find out the character code, we will use the formula to character minus offset. And for the new character code, we will use character code plus key and divide it with 26. Then the new character code plus sum will be offset. Now for this part, here are two parts: encode and decode in different code. In the encode part, if the key is not numeric, the message will be showed that key is not valid. Then the ciphertext will be empty, and the key will be divided by 26, and the plain text will be returned in character, and the main encoding part will be plain text will convert into ciphertext. And for the decode part, the same, the plain text will be empty if not the key is not numeric, and we will find the key by dividing 26 and plain text, and finally the plain text will be revealed. But for the decode part, we will use negative key instead of the positive one. Now we have make a module to test the code if it's run correctly or not. So we can see that the code runs correctly, and we can convert plain text into ciphertext using this code. Now we will talk about the one-time pad. If we now see an example for one-time pad encryption, then we have the same box with the index and the characters, and we will take a plain text attack, and we will convert it into ciphertext. From the Caesar cipher, the one-time pad is slightly different. The key is numeric in the Caesar cipher part, but in one-time pad, the key will be string. This means it can be number or character or any type things. So we will use the same formula like Caesar cipher, which is C equals to P plus K. That means plain text plus K. Here 17 plus 1 equals to 18, 20 plus 17 equals to 37. Here some twist. If the ciphertext is greater than index, then uh, the same the same rule will go like the Caesar cipher. We will divide the ciphertext with by 26. If result will be in fraction, then we will minus the integer number, which is 1, and in the result in fraction we will always use the upper bound. If the main plain text is greater than the key, then we will only use the numbers like the main plain text. Suppose we have a key which is elephant, and we have a plain text which is attack. So elephant, in we will only use the first 5 characters. This is how we will do one time pad encryption. Now if we see one time pad code, here we have same code like Caesar cipher, but with some changes. Here we have written a code for replacing characters, which if the character is not string, then we will return the character, and the offset 65, then we will lower, and offset equals to 97. Then the same thing, and we will here is a new part for one-time pad code for finding key in character. If the key is not character, then we will return to the main portion. For the character, we will we then the finally we will find the character using the formula. If we now see decode and encode part for one-time pad, for decoding for decoding the plain text will be empty, and if the key is not string, and here is the rule to skip the first part so that there cannot be any can't be any space for any type of um, miss for any type of miscommunication, so that the main value is the main value is wrong. For this we will use a range for plain text. We for where we will replace the character. For finding key we will skip and then length then divide it by the length of key. Then we if the ciphertext is not like index, then we will increase the number of skip. Then finally we will find the plain text from the ciphertext. And for the encoding part the same, but here we will use the positive key for the encoding part, and we will find the ciphertext from the plain text. And for in the decode part we have here use find minus find key, which means negative key for decoding part. By the code we have run the code, and here is the result, which works perfectly. That's it for this topic. Thank you. If any questions, let me know in the comment section.